Hope you guys are all enjoying your week off from school. We'll obviously wait for like everyone to start joining, but we're going to be going through some more problem solving data analysis type questions for today's class. And then I think we might be able to finish a little bit early so then we can have like some open discussion, any additional questions, that kind of stuff. But we will see. All right, so we'll get started going through like the material for today. As people are joining, just remember to put first and last name into the chat box for attendance. Thank you again in advance for that. But we're gonna get started. I know if you guys were in the morning session today, they went through like the first part of problem solving data analysis type questions. We're gonna finish up like the end of that. This topic, like on the DSAT in general, it doesn't come up a whole lot. It's kind of similar to geometry in a sense, but both this and geometry, there are so many different topics that they could choose to put on the test, which is why it's so important to go through all of the topics that have to do with like problem solving data analysis and geometry. So even though it's not a lot of questions on the test, it could be a wide variety of what they're asking you. Again, this is just the schedule for the week. Obviously, we're almost at the end. So problem solving data analysis part 2 is what we're going to be doing today. Tomorrow, it's going to be like a mock test kind of situation. So you'll be given, I know the paper DSAT, which is what you're going to be using, typically gives 43 minutes to do the 27 questions. But, you know, for the sake of going over some of those questions, we're gonna have you guys do about 35 minutes of like test taking and then 25 minutes of like reviewing those paper tests. So it's gonna be like immediate feedback on some of those questions. And also that will not be me tomorrow. It's gonna be Matt from the in-person class. I'm gonna be away, so it'll be back to Matt. These are all the topics that come up within data analysis and problem solving type questions. This morning in the earlier session, you guys went through the first about 4. Now we're gonna just take a quick look at some of the other materials that are the rest of those topics. So data representation, scatter plots, linear and exponential growth does come up again as like one of these topics, but I don't think I cover it in this PowerPoint only because we talked about it a lot in the other PowerPoints. And then probability, frequencies, like data inferences, like being able to like see a, I don't know, table with data, be able to pull or draw conclusions from it, and evaluating statistical claims. So these are like the topics that we're gonna kind of go through. This PowerPoint is a little bit shortened from what you guys probably saw in the in-person class, but the full PowerPoint is available in the Google Drive. So if you've already emailed me and asked for the Google Drive, it has all those PowerPoints in there. And I've also been adding additional like Desmos review type materials or like just random questions where I'm like, oh, I feel like this needs like a further explanation for anyone to look back on. So let's get started. Data representations, very broad term. Basically, we just want to remember like with graphs, like the representations is typically talking about like bar graphs, histograms, dot plots, line graphs, scatter plots. I think even just like tables and that kind of stuff. So anyway, data could be represented. These are just words to look out for when you're looking with line graphs or any other types of like scatter plots, that kind of stuff. So if the slope is increasing, they'll typically say increases, rises, grows. That means upward trend versus downward trend is that negative slope. Flat trend is kind of also, I don't know if you guys in school have heard about like correlation, or they'll say like positive correlation or negative correlation. No correlation would be like if the data points are all over the place versus negative. Typically, it looks like a negative slope. No correlation. And then there's also positive. So if the trend looks upward, it's increasing. If it looks downward, it's decreasing. There's also the difference of shallow versus steep. So if it's increasing really fast, it's a more steep looking curve or line. If it's slow growth, it'll typically look something like this, very slow, versus this would be fast or like more rapid, quick growth. Box plots. So this is something that I like to cover mainly because in the past few years of the SAT, they've been throwing these on there more and more and more. Like if you look at any of the original practice tests of like old SATs, they never had box plots on them at all. And then all of a sudden in 2022, 2023, they started throwing them on the test. So I'm sure they'll continue to pop up on the digital SAT. So a box plot is more of representing data in a way that we see median, which you guys talked about this morning, I believe, when you did like center of spread and all of that kind of stuff. So it's a way of showing your median. This line right here represents your median. The box itself represents 50% of your data, because the median is technically your 50% point. This would be your 25% point. This is your 75% point. It's representative of, the point that the 20, like if you lined up the data from 0 to 100, almost like 0 to 100%, the 25% mark would be that line on the box. The box itself is 50% of the data. So whether the box is like this or whether the box is like this, kind of shows you how wide like the data is spread out. So if the data is like super close together, then the box should be a lot smaller. These lines on the outside are your minimum points and your maximum points of your data set. So those lines are typically telling you how large your range is, like what the range of the data is. So box plots, also known as box and whisker, I believe, is probably what you guys were taught in like middle school when you were learning these. Those endpoints, those whiskers, are telling you your minimum data point and your maximum data point. All right. So here's just an example, like for data representation using histograms, shows the size distribution in square meters of, that's supposed to say of houses on Elm Street. According to the histogram, how many houses on Elm Street are between 500 and 100 square meters in size? So once you guys have an answer, you can direct message it to me in the chat box, and then we'll talk about it. So this is just helping us like know how to read like these types of tables. Also, I don't know if I've let anyone else in to the meeting since we got started, but if you haven't, just put your first and last name into the chat box also for attendance. I'm seeing some answers. Everybody is right so far. Alessandra, do you want to explain how you got your answer? Like
so I looked at, yeah. So I looked at like the graph, and it's asking how many houses are between 50 and 100 square meters, and if you look, it shows 4.
Yeah, right here, that 50 to 100 mark, that it's just going to be 4. So your frequency is typically on your y-axis versus whatever we're looking at. In this case, area is going to be on your x. Something to be careful. So the answer is 4. Yep. Something to be careful of, which I don't know if the SAT is going to do this as much as the ACT normally does, but something called a cumulative frequency table. So in that case, whatever, like, let's just say it's like looking at people's grades in a class. It would be like from, let me see, like, how would I explain this? So for example, the number of people who got like a 50 to a 60 would be this many, but then it would be like the people who got from 50 to 70 would be this many. So it continues to increase. So it's including these people in this new number. So it continues to build off of that original amount. So instead of there being like 10 people, now there's 30 people that are in that range, including the 10 people from before. So it continues to grow if it's cumulative frequency because it's adding up those ones from before. Because then it would be like 50 to 60, but this would be 50 to 70, etc. So that's something to be aware of. I'm not sure if the SAT will do it, but we don't know yet because this is the first time they're doing the digital test. So we don't know what kind of new stops they're going to pull out in regards to this topic. This kind of graph. So again, I guess you could like think of this almost as like a algebra type question, right? You could think about this as just what is it called? I guess just like basic algebra like techniques, not really advanced math, but it's also considered like data representation. So I'll let you guys take a look at this one. We're trying to see how many minutes did it take for the pizza to increase its temperature by 4 degrees Celsius. So it's like a multi-step type problem. Or like, how do we think we would start something like this? Anyone can raise their hand. Barnabas, how did you like start this question or like what was your first instinct?
I forgot what it's called, but did y final minus y initial over x final over x initial,
Yep. And then
and then
what'd you do?
that equals the slope, and then I found the slope to be 8, so it says, and you're trying to find when it rises 4 degrees Celsius, which is half of 8.
Yep. Yeah, so right now our 8, like I know that's slope and I know we just found that this is slope. What are the units on this? Usually with slope, if it's just y and x and we're doing something like that, like we don't really care about any units, but like what are the units on this? Like what does this really mean if it goes up by 8? Okay, someone put in the chat box degrees per minute, which is true. So it's our y over our x is typically our units. So 8 degrees Celsius per minute. They want to know how much does it take to increase by 4. So now we know we can go up 8 in 1 minute. So to go up 4, we're going up 4 in a half a minute. So, it would be, I was about to write 4. To go up 4 degrees Celsius, it would take 0.5 minutes. So for me, at least, I feel like using those algebra techniques in a problem like this is still very helpful to getting to that type of answer. Like if I know what my slope is, then I know how long it takes for me to go up however many degrees Celsius in however many minutes. If we tried to just look at the graph, it would be kind of difficult. But I mean, if you wanted to make that guesstimate and if there were answer choices, we could have looked here and been like, it kind of looks like we're going up 4 in half a minute. Maybe. Like if there were answer choices, then yeah, we probably could have gotten away with guessing it was 0.5. But, to have a surefire way of getting to our answer, we probably want to use like a slope formula. So this is, yeah, how to find slope. Y2 or y final minus y initial over x2 minus x1. Same thing, rise over run. All right, let's keep going. So this one kind of, giving us some measurements again with degrees and density. And then they're trying to get us to say what's so significant about t is equal to 4. So I'll give you guys a minute to read through those answer choices and then let me know what you're thinking the answer might be. All right, so far we've got one answer, 2 answers. So we only have two answers, but does anyone think the answer is B? Because I know sometimes people think the answer is B. All right. Well, basically the people that answered, they responded with D. That's the correct answer. So the answer choices themselves aren't like too difficult with this problem. A lot of the times when they're asking you to look at a graph, they're typically going to ask you with t equals 4, they're referring to the maximum. So looking at ones that are talking about a maximum makes the most sense. Some people will accidentally choose B, but this is the incorrect units, right? Like that's not the correct units for what we're looking at. We're looking at 4 degrees Celsius. One other thing, like when they present graphs like this, a lot of time they love to look at the y-intercept. So that's something always to be careful of with the y-intercept, is because sometimes it might not always be 0 here on the graph. They might have that line up and it might be at 30. So when we're trying to come up with a line of best fit or anything like that, we just want to be careful that this is actually 0 when we're trying to come up with our line. So this will come up more with scatter plots, because scatter plots, they love to be like, okay, let's plot a line of best fit, or like what line would make the most sense like for these data points. So line of best fit is, at least for the purposes of this test, mainly going to be linear. Y is equal to mx plus b. Positive versus negative correlation we kind of talked about when we were talking about data representation. So I'm not going to, spend our time reviewing that again. But yeah, y equals mx plus b, super important when it comes to a scatter plot or like trying to come up with like that line. So this is one of those examples. They're giving us an equation based on the data points. They want to know what is the world population in the year 1981. Two different ways you could do this kind of problem, but I'll let you guys get started. Let me know when you have an answer. Send it to me in the chat box, and then we'll review. All right, so I have about one answer right now. I know there's 15 of us in here. Doesn't matter if you send me a wrong answer. All right. So we've got a few answers. Everybody's getting the same thing. Afzel, do you want to explain how you got your answer?
Yeah, so I just plugged in 31 and x of the equation, and I got 4.51.
How'd you choose 31 for X?
Oh, since it's the years, like, since 1950, I just did 1981 minus 1950.
Yeah, exactly. So that gives us 31. We can plug in, they gave us the equation. This would be really good, if they didn't give us a graph, plug right in. We get an exact answer. Another way we could have done this, if we didn't, for some reason, we didn't see the equation, we're like, oh, I can't see that. We could have just looked on the graph. So as we were saying, 31 is the number of years after 1950. We could have just like gone up from that point, like on the graph, and it looks to be at about 4.5, and none of the answer choices are even close to that. So we would know that it would be B. All right, let's keep going. So this is what I was talking about when we have to come up with one of these equations. Easiest way is probably by looking at our y-intercept, trying to build based on that. In this situation, all of our slopes are positive because there's a plus sign in front of them. But if they weren't, we could start eliminating based on positive or negative slope. But yeah, most of the time we could probably just look at the graph and kind of like guess, like without even plugging in points, like what our answer should be. So you guys take a look at this graph, take a look at those answer choices, and then let me know what you're getting as your answer. All right. Alessandra, do you want to explain how you got your answer?
Yeah, so I looked at the y-intercepts and I knew like I could cross out C and D. And then I plugged in for both, right? I plugged in like one of the points to see like what would match, and it came out to be B. So I plugged in 4 and then I plugged in 5 and they like matched.
Yeah, exactly. So you could plug in 4, plug in 5 into both of those and try to see which ones match. Also like looking at those points, it kind of looks like, okay, from 0 to here, it looks like we're going up about 2 to there again, another 2. So it looks more like I'm going up 2-ish than 0.5 or 0.4. So another reason why we want to go with B, we can always, plug it into Desmos to see. But the issue with plugging this into Desmos would be, would I have to sit here and plug all these points in? I don't know. Like if that would be my most like time efficient way of doing this problem. Another thing is like you could just plug in both of these lines into Desmos and see which one looks the closest. But again, it's like you wouldn't be able to visualize the points unless you plugged all those points in, and it might take a little bit to do that. So yeah, definitely eliminating based on y-intercept first and then trying to look at what slope makes the most sense. Probability, relative frequency, a lot of times they'll do like 2x2 tables. So it's all a matter of figuring out what should be our denominator, what should be our numerator. It's typically based on the question. So they say, like, if one of the students from the survey is selected at random, that means out of everybody, right? Versus if they say, if we're looking at the people who play video games, how many of them watched like gaming live streams, right? So that would be a different denominator. So it's always like this first part that's letting you know what should be the denominator. Let's take a look at this one and then keep going just so we have time to do all those questions that are at the end. Human blood can be classified into 4 different blood types. It's characterized by the presence or the absence of the rhesus factor. This table is showing those blood types and the rhesus factors for a group of people. If one of these people who is rhesus negative is chosen at random, the probability that the person has blood type O is 1/2. What is the value of X? All right, how are we going to set this up? How are we going to find out what X is if, we don't know a total? What are we going to do? What is anyone like thinking of the first step for this? What about if we use this sentence right here? What do we think?
Can I say?
Yep. Anybody could say it anytime. So yes.
It says that the probability, if the people chosen, which is the group, have are negative, and it's asking if only in the negative group that the probability of a person that has type O is 0.5%. I think it's saying so. It's basically so since O is half and it's 3, 100% is 6. So 1 plus 1 plus X has to equal to 3.
Maybe I shouldn't have used X right there. Let me just put T for total. Yeah. So the total would have to be 6, like you said. Then we know all those people that are negative on the bottom. And then we solve for X and we got what?
X is 1.
X is 1. Yeah, exactly. So being able to set up these types of proportions to solve for a total, like they're giving us enough information in order to solve it. Even without telling us, you know, like some tables, they would have added this up. They would have said, this is 6, this is 125, this is blah, blah, They don't always have to give you that information if they tell you one of those fractions or probabilities. So we could use that to get to our answer. So this is exactly how we set it up to find the total number of, like, these are the resist negative. And then we just solve for x because we know it has to add up to be 6. Data inferences and statistical claims. So this is kind of, there's a lot of just like words on these slides. Oh, sorry, let me go back. How did I set up the proportion? So they said if one of the people who is negative, so that means my denominator has to be everyone who is negative, is chosen at random, the probability that the person has type O, so it's like they have to be O negative. That has to be our numerator. So it's O negative over everybody that's negative is going to be equal to 1/2 because they told us like that's the proportion. Like the probability that we pick someone who is O negative out of all of the negative people is 1/2. So that's how we're able to set up this proportion. And the one thing that was unknown was this, everyone who's negative, we don't know how many people that is because of that X in there. So that's how we found that total. We could have, you know, from the beginning, we could have plugged in that T is 1 plus X plus 1 plus 3. I just felt like doing it in 2 separate steps to try and show you guys the proportions a little bit better. But setting it up like this is usually how it's going to go for a lot of these probability problems. So once they say if one of these people is negative, that's usually your denominator. If blah, 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 given that the person is this, that's your denominator. And then your numerator has to be, you know, whatever characteristic it is out of the people that are the denominator. Yes, Darius said, could we do 1/2 is equal to, yeah, we could have done 1/2 is equal to 3 over 5 plus X. We could have solved it this way to immediately solve for X rather than finding that total is 6. Either way, however your brain works, any way is possible. And that way you probably want to cross multiply. You're getting 5 plus X is equal to 6. Very similarly to what we did before. This stuff is basically just a lot of definitions. Sometimes the test likes to see if you can like determine if a sample is representative of a population or if it makes sense to estimate something and then say that it applies to the whole population. So certain things with this, which I think is going to pop up again in the next subtopic, would be like, if I went, let's just say our town, we all live in the same town, our town wants to put in a new dog park. And then I tell you guys, okay, I went around town and I stopped everybody who was walking a dog and I asked them, do you want to build a dog park in our town? And I found out that everybody, like 90% of those people are in favor of building a dog park. Is that like fair to say that the whole town wants a dog park if I only surveyed people who were walking dogs? Kind of rhetorical question. The answer is no. So if I'm only asking like certain people something, it's like I pick them because of a bias or something like that. Like I pick them because I know they're going to support what I want to do. So they're not like representative of a full like population. Margin of error. So this morning, you guys, if you went, might have talked about standard deviation. Margin of error is very similar. Again, it's not something that we have to actually know how to calculate. Same thing with standard deviation. We don't need to know how to calculate that. But what we do need to know is that basically this part right here is the most important part. The larger a sample is, the smaller the margin of error will be because we're sampling more people. So the way the calculation works, it's basically saying if we sample more people, our margin of error will be smaller. The margin of error is basically stating that if I get, I don't know, let's say I measured a population of prairie dogs and I found out that their average weight is like, oh, I don't know how much a prairie dog weighs, but let's just say 72 pounds with a margin of error of like 6. So that would mean it's like 72 plus or minus 6. So that means most likely like a majority of the prairie dogs in this population are going to be between, what is that, 86 and 78, because that would then be our range. So, oh, sorry, 66 and 78. So margin of error is kind of just saying like, okay, we sampled everybody, but you know, the mean actually might fall somewhere between this range rather than definitively being 72 or something like that. We'll take a look at some examples, but let me just see. Okay, this is all we had left. Good. So this one is an example using margin of error. So they say about 74% of the people at the gym go to the gym at least once a week with a margin of error of 3%. What's the most appropriate conclusion about all members of the gym based on the given estimate and the margin of error? So remember, like that margin of error is supposed to be giving you like a range. So I'll let you guys look through the answer choices and then try to figure out which one you think is the most correct. I know some of them sound good, but whichever one you guys think is most correct. All right, so we're getting some answer choices. Someone's asking me if confidence intervals on the SAT. Not, it really isn't. Like a 95% confidence interval would not be on the SAT, but kind of thinking about like, I don't know, with margin of error, I kind of think about confidence interval just because like it makes me think a majority of the people are like in that range also, you know, but it's technically not on the SAT, it's just margin of error, which is like this concept, which most of the time it's pretty easy to eliminate some of these answer choices. Let's go through these. So we have a few answers, they're both correct, but let's go through one by one on these answer choices real quick before we skip ahead to those last questions. So it says Anya's 71% to 77% sure that less than half of the gym members go to the, okay, well, this was supposed to say gym at least once a week. Okay, that's all spelled wrong. That was not me, I swear. Like I did not type those. This one is not accurate because like when we're talking about this percent, it's not how sure she is about a number. It's supposed to be 74% of the people go to the gym at least once a week. So why would it now be half of them? Like that doesn't really make sense. It's not about how sure she is. So it's not going to be A. B is the actual correct answer, so I'm going to skip it for now. C says at least 71%, but no more than 74% of the gym members go to the gym at least once a week. This isn't accurate because you know, people could still be falling outside of that range. We don't know. Like, just because we're saying it's 74 plus or minus 3, there could still be people that we're not entirely positive that it's definitely in this range, right? Like we don't know. But also if it was but no more than 77, that also would have still been wrong. So it's just like it's likely that the percentage of people that go are between this. It could be 70, we don't know. We're just saying with our margin of error, like we assume that it would be in this range, which is why it's B. D, again, like it's just using that number as very like definitive. That's why we wouldn't want to choose something like that. This concept is a little confusing, I know. But most of the time I feel like you'll be able to eliminate the ones that don't seem right in order to get to your answer choice. Statistical claims, what we were talking about before, like bad sampling, just making sure things are like representative of a population. Random means that we're asking like anyone in the population has an equal chance of being selected. If you take a statistics class, you'll learn all about different sampling methods and all that kind of stuff. But for the SAT, it's more just we need to recognize, is this okay or is this not okay? Like for the multiple choice almost. Same thing, drawing conclusions. There's surveys, there's controlled experiments. Something that you guys have probably heard before, but I don't know because it mainly comes up in statistics classes. I feel like they'll typically say stuff like this. Correlation does not always imply causation. So just because things are correlated doesn't mean there's a cause. So we could say, you know, in the summer, for example, in the summertime, let's say sales of ice cream go up and shark attacks are also up. So we couldn't say like, oh, because the sale of ice cream is up, shark attacks are up because of the sale of ice cream. It's probably because of warmer weather. People are buying ice cream, people are in the water more, shark attacks are more prevalent. I don't know. Something like that. So we can't always just say like, oh, this causes this because they're both correlated with each other. So that's something to be aware of as well. This one I'm just going to skip so we can get to these practice problems. But I'll let you guys start working on this problem. If anyone has any individual questions, they can ask now or in the chat box. But we'll start with this one. And I think there's about 4 or 5 questions. Yeah, 4 questions that we're going to get through. But once you guys have an answer for this one, just send it in the chat box and then we'll talk about it. Oh, this one's super easy. This was like literally straight from one of the paper DSAT, so it's not like I'm purposely choosing like super easy ones. Okay, a lot of people getting the answer for this one. It is going to be 40, so we just have to go through, look what our group number was, and then check out what that frequency is. Number of cans. If we wanted to find, let's say, going back on what you guys learned this morning, if I wanted to find mean, like the mean number of cans collected by each group, how would I figure that out? Like if I wanted to know mean cans. Yes, Afsel just responded. You'd have to do 419 divided by 10. And then that would give us like the average between like the groups, like how many each group collected. Perfect. Again, yeah, I took most of these questions that are on this one from like a paper DSAT, so it is College Board questions. So if they do seem easy, I don't know what to say. Table gives the distribution of votes for a new school mascot and grade level for 80 students. If one of these students is selected at random, what is the probability of selecting a student whose vote for a new mascot was for a lion? Okay, so as you guys put in your answer for this question, I'm going to pose another question using this data. So I'm just going to write it down here. So that's an additional question for you guys once you solve the initial question. All right, we're getting a bunch of answers in the chat. Let's start with the first question, which is the one that's actually, printed on the slide. If one of the students is selected at random, what is the probability of selecting a student whose vote for new mascot was for a lion? Daria, do you want to explain how you got C as your answer for the initial question?
So first I just looked at like the number of students in total, and then I saw the ones that just voted for Lion, and then I just simplified it down to 1/4.
Yeah, so we would have had 20 over 80. That's giving us that 1/4. So we are getting C for that one. Let me use a different color highlighter. We're getting a few mixed answers for the second question that I posed. So I'm saying if a sixth grader was chosen at random, what's the probability that they chose Badger as a mascot? So our denominator now would be the number of sixth graders because we're choosing out of only sixth graders. So we can only pick out of the sixth graders. Our denominator is 23. What's the probability they chose Badger as mascot? Also, if we're only choosing out of sixth graders, we can only choose the sixth graders that picked Badger. So we can only choose the 4. So in this case, our answer would be 4 out of 23 for that. So it's always going to be dependent on what the if is or what the given is. They could have done this in reverse. They could have said, if like we're choosing out of the people who chose like Longhorn as the mascot, what's the probability that I choose a seventh grader? In that case, it would have been, let me use another color. It would have been 6 out of 14. Like if I'm choosing out of the people who picked Longhorn, what's the probability I pick a seventh grader? It would be 6 out of 14. So that's how we're like attacking those kinds of problems when they're not saying it's out of everybody. We have to choose like what our denominator is, what our numerator is. Let's take a look at this one really quickly. Poll results. So we have 2 different candidates. There's a total of 803 voters selected at random. We're asked which candidate they would vote for in the upcoming election. According to the poll, if 6,424 people vote, by how many votes would Angel Cruz be expected to win? Be careful as you're approaching this one. There's multiple steps we have to jump through to get to our answer. There's also a few different ways that you can set this up to get to your answer, but I'll let you guys try it out. And remember, when you do get to your answer, just be careful, double check what the question's asking. All right, let's start talking about this. James, do you want to? Oh, wait, your mic is broken, right? You're the person
Wait,
who
can you hear
recorded.
me?
Oh, yeah, no, I can hear you.
Oh, okay, good.
Yeah, I want you
So,
to talk about how you changed your answer.
because you said like make sure to reread it, and then I reread it, and I was like, oh. So at first I set up like a proportion.
Mm-hmm.
So I set it up as 483 over 803 is equal to x over 6,424.
Yep.
And
And
then
I'm
I solved
guessing
that.
you got what, 3864?
Yeah. And then I subtracted 6,424 minus 3864 to get 200, I mean 2,560,
Mm-hmm.
and then I subtracted that from 3,864 to get B.
Right. Yeah, because okay, so if you take the 6,424 minus 3,864,
Yeah,
what was that number again?
2,560.
So that would be the number of votes that Terry gets. So if we subtract it from the 3,864 minus the 2,560, we should get the 1,304 as our final answer. Like that's the difference between like their two votes. So we're subtracting those because we want to know the difference between like how many votes did Angel win by. Another way we could have done this, another proportion we could have set up is by saying, okay, how many in this situation, how many votes did Angel beat Terry by? So that would be I'm using my calculator, aka my phone, 483 minus 320 because we have access to it on the test, so why not? We'd have 163 over the 803. So that would be the difference. You could also use this proportion and do a little less work. Then we would say X over 6424, and this would also get us 1304 as our answer. So using the difference as our original proportion might help us get to the answer a little bit faster. But again, multiple ways. You also could have set this up, to find out the 2560. You could have said 320 over 803 equals X over 6424. However you wanted to do it, if you wanted to figure out what the percentages were for both of these first and then go about it that way, totally another way you could have done this. But our answer is going to be B. We always want to reread that question because they want to know how many votes is he expected to win by. Like, sorry, I think they literally wrote this question wrong. It's supposed to be by, yeah. Sorry. So if you did put C, so sorry. Should have been clear. Win by. All right, last question for today. I know we only have 3 minutes, so let's try to finish this one up quick before English starts. The dot plots represent the distribution of values in data sets A and B. Which of the following statements must be true? The median of data set A is equal to the median of data set B, or the standard deviation of data set A is equal to the standard deviation of data set B. I know this is kind of a concept that you guys might have seen this morning if you were in class, but I'll let you guys read through it. Again, I'm gonna put my email into the chat box for you guys if you want access to any of these PowerPoints or any of the PowerPoints from the in-class. I have them all in a Google Drive with a few other resources. So if you want them, just email me afterwards. I'll send you the link. This is our last question for today. And then tomorrow you guys will be doing like practice test work, like practicing as many problems as possible, really. All right, so we have some answers. I know people are probably still trying to look at this. Steven, do you want to explain why you chose A as your answer?
I chose A because 13 is in the middle of both data sets.
Mm-hmm.
And, I was just feeling like I think standard deviation is like the amount of like a curve, and I think B has more like curve going down and stuff. So yeah, I know two is wrong, so that's how I got my answer.
Yeah, so 13's in the middle of both, so it's also when you like cross out all the numbers to get to your middle point, they have to be from low to high. So exactly, one is definitely true. Standard deviation isn't going to be equal. We don't need to know if one is greater than the other or vice versa. We don't have to know that. But what we do know is that with B, like most of the data is towards the end. And then with A, it's kind of like all over the place, but more data is towards the middle. So if your data is more concentrated towards the middle, then like the outside, it's going to have a different standard deviation because of the way the data is set up. So that's why we'd get A as our answer for this one. But that's basically all I have for you guys. Standard deviation of A should be lower. Yeah, it should be lower than the standard deviation of B. Yes. But that's all I have for you guys today. Obviously, we don't have time for any other questions, but yeah, just shoot me an email if anyone wants any of the PowerPoints. But other than that, you guys are ready for English.
Hi.